Hello everyone, welcome to the new series of R&D Talk. Just to remind you, that's the series where we share the insights from the R&D experts and enthusiasts about certain innovative topic that brings the attention of engineering community and SoftServe customers. So today's topic will be all around something that SoftServe is not typically perceived of. So SoftServe is not only about software, but also we have very strong expertise in hardware. And hardware is not only about building the devices, it's also about having the processes that connect the initial business idea with all the engineering execution from the design and prototype over to the optimized software on top of that hardware. So today, our speakers will dive deeper into the SoftServe hardware lab and the cases that emerged over the past decade almost was in that direction. So let me introduce you today's speakers. We'll have Dmytro Dudchenko, who is R&D Product Manager and the hardware development expert with over 9 years of experience leading hardware lab initiative. He specialized in complex technological concepts and converting those into the ready hardware products into the market. Andrii Khusainov, R&D Cluster Lead at SoftServe. He is specialized in hardware-focused innovation, has been working on the 3D scanner initiative that you may have heard of for quite a number of times. And with 15 years of experience in the IT industry in general, he has been focusing on the telecommunication, computer vision, and leading advanced developments across R&D. And Andrii Khusainov, R&D Cluster Lead with over 15 years of experience in software design and hardware optimization. His work focused on the high-performance computing based on the GPU, CPU, and even William DPS with application of numerical methods, physical simulations, and computer vision on those types of hardware and custom processors. So that team will share with you today the insights and open the door on the work we are doing in that direction. Encourage you to ask the questions. All the questions will be answered in the end of the session during the Q&A. And yeah, hope you enjoy. So pass the word over to Dmytro.
Thanks a lot for introduction, Bogdan. Hi, everyone. Thanks for joining us today. Our goal for today is to show you how we work with hardware, to share our expertise, show our vision, and position the hardware lab as a strong technical partner within SoftServe. Let me walk you through what we will cover today. First, why the hardware lab exists and what problem it solves. Then our strengths and what make our approach different from typical hardware outsourcing. We will show you what we offer, dive into real cases, and share the trends shaping our current focus. And finally, how to engage with us and where you can be supported by us. Let's start with the context, where this initiative came from and why it matters. At SoftServe, hardware-related requests have been around for years, but they used to come in different shapes. Quick POCs, feasibility studies, legacy upgrades. Some of those grow into real projects. Others never move forward simply because there wasn't clear structure or shape process. Over time, we notice repeating patterns. Clients need fast prototyping, embedded development, and support for outdated systems. So we decided to bring all of this into one structured unit, and that's how the hardware lab was born. Let's look at 3 real challenges that pushed us to build this lab. First is speed. Many clients need results fast. A working prototype, feasibility check, or even just clear yes or no in matters of days. Second is risk. At early stage, unclear system architecture or missing hardware validation often blocks process. And third, outdated infrastructure. Many companies still run on legacy platforms that are hard to integrate or modernize. The lab helps tackle all three with modular toolkits, simulation frameworks, and modernization playbooks we have refined over time. But our goal wasn't just to build a delivery unit. We wanted to create a platform that could scale innovation. The lab gives clients one clear entry point, connects architecture, delivery, and R&D, and helps retain knowledge across projects. It let us run applied R&D that turns exploration into a real solution fast and with less risk. And by combining hardware, software, and AI into one flow, we help clients to go beyond POCs and bring product to life. Let's take a look at what we actually do and what makes our expertise unique. We cover the full engineering stack, from schematics and layout to firmware, connectivity, and runtime optimization. Everything is done in-house across three main levels: hardware, middleware, and software. At the device level, we design PCBs, run simulation, write firmware for microcontrollers, and co-validate hardware and software. At the connectivity level, we build reliable IoT communications like low-power wireless protocols, secure cloud interfaces, over-the-air updates. At the intelligence level, we optimize embedded runtimes, offload compute to the edge devices, and tune AI models to run efficiently on real hardware. What makes us different is that we don't stop at the board or firmware. We go all the way to system-level optimization, combining design device with high-performance computing and embedded AI when needed. Why does it matter? Because clients get end-to-end engineering with one team, reducing complexity, project risk, and cost, while delivering better result performance by per watt, per dollar, per millisecond. So how we do actually work? We always start with a problem, not just list of tasks. In discovery phase, we try to fully understand the challenges and look at technical and system limitations before we start designing anything. Then comes the building phase, where we design the system, run simulation, create prototypes, and check if the idea really works. After that, we move to optimize, where we adjust algorithms to run on real hardware, improve runtime performance, and find the right balance between speed, power use, and cost. The most important thing, our teams work together from the very beginning. Hardware, software, and AI engineers are always on the same page. As a result, clients get scalable, ready-to-use solutions, and we move faster with fewer mistakes and less reworks. So now let's talk about what we actually offer, the core services, what drive most of our hardware work. First, legacy hardware extension. We help clients modernize all systems without full replacement. This means adding IoT connectivity, real-time analytics, and new control layers while keeping the existing hardware in place. Next, custom IP replacement. Many teams struggle with expensive or inflexible third-party libraries. We help replace them with in-house logic using FPGAs, custom firmware, or accelerators to give client more control and low cost. Third, hardware penetration testing. Security is often an afterthought in embedded products. We run deep analysis on firmware and hardware and define weak points before attackers do. And finally, faster hardware launch. We support clients from idea to prototype in just few weeks, combining rapid design, embedded software, and system validation in one flow. Each of these directions solve real problems and bring clear business value. And in next section, we will take a closer look at each one in details. Let's start with the first one, legacy hardware extension. Many companies still rely on old hardware Replacing it is often too expensive, risky, or even impossible due to certification or integration limits. Instead of replacing, we help modernize by adding IoT models, telemetry, and embedded logic that makes existing systems smarter and more efficient. We've seen this approach work well across industries, from modernizing production lines and vehicle control units to extending the life of medical devices and simplifying updates for consumer electronics. This offer is great for teams looking to extended system life with low risk and cost-effective upgrades. The result? Less downtime, lower support cost, longer equipment life, and better ROI through smoother transformation. And now Andrii will show a real project where we use this approach. Andrii, please.
Yeah. So we had the client came to us and the main ask from them was to take several pieces of hardware, which were actually different vendors, and some of them were legacy hardware, some of them were quite newer with some bigger capabilities, and combine everything into one application in one ecosystem, and make it work, make it a seamless experience to the customer. So we team up with our awesome UI UX design office to do the POC, which went for very fast. It was like 4 weeks POC to make the application which will show our client the value of this kind of solution. Next slide, please. So we had several pieces of equipment. In this case, there were toothbrushes, Bluetooth toothbrushes with different level of data streaming to their own ecosystems. But to combine all this ecosystem in one, it was not really feasible. So we actually used our engineering skills to basically reverse engineer their protocols and use combine all the devices into one application that then can be integrated to one ecosystem. And in 4 weeks, we built the application on the iOS and Android to demo it and show to the client how it can be done. Of course, the application was standalone and showed most of the functionality minus the cloud and gamification, but still all the legacy equipment was integrated successfully with our POC. So yeah, that's how we can do it. And in general, we had other projects in which we actually integrated legacy equipment with some degree of reverse engineering the protocol or using standard protocols into one ecosystem to give them like new, better life, I would say. Yeah.
Yeah, great. Yeah, thanks a lot. So second offer is custom IP replacement. Many teams rely on third-party libraries or models that are expensive, limited, or hard to customize. This creates vendor lock-in and makes it harder to control performance or manage long-term costs. With this offer, we help replace external IP with custom firmware, logic, or accelerators, built specifically for clients' needs. We've seen this approach work well in different industries, from replacing visual libraries in factories and communication stacks in smart devices to rewrite firmware in medical tools and optimizing battery system in electronic vehicles. It's a great option for a team who want to reduce licensing costs, take full control of their features, and build flexible solution around their own needs. The benefits are clear: more predictable performance, lower costs, and freedom from vendor restrictions. Next, Yuri will share a real case where we applied this in practice. Yuri, please.
Thank you, Dmytro. So this client came us with an issue that he had legacy device and going to actually release new equipment. And the problem was actually with the upgrading and supporting both devices that actually in general is incompatible. A legacy device was based on some legacy custom Linux and actually end-of-life equipment that was not supported, and the framework and methodology was also outdated. That didn't allow client to actually quickly upgrade the device, fix any vulnerability regarding security, and to give better experience for the actually clients. And the goal of the project was actually to replace the legacy framework, or, like Linux kernel, with a maintained by Yocto product. Actually brings very flexibility to quickly update the image in a very robust way using dual boot. Also quickly fix all legacy and current issue with vulnerability connected to the wireless and other connectivity, and unify the way of maintenance, the old device and the new one. It actually allows more smoothly even introduce newer equipment into the field without worries of old one. So the key technology was here, like embedded Linux, Linux driver, Yocto, over-the-air update, and we succeeded it. We quite in limited time provided the solution and methodology how to actually upgrade a legacy device with a new Linux kernel that is supported dual boot to fix almost all vulnerability related to the security, especially connectivity, and unified the OTA process over the all clients and equipment.
Okay, thanks a lot. Thanks a lot for this. The third offer is hardware penetration testing. Today, many connected devices are at risk of being physically opened, damaged, or hacked through firmware, but security is often checked too late or not at all. This offer helps team find and fix problem early by running real attack scenarios and testing the hardware and firmware for weak points. We've seen this approach work well across industries, from testing robotic controllers in factories to securing in-car system, smart home devices, and connected medical equipment. It's especially useful for companies building connected products in regulated or high-risk environments where trust and compliance really matter. Outcomes: better protection from attacks, easier compliance with standards, and more trust from users. And now Andrii will share a real example from the field.
Yeah. So we had a request from a customer to conduct the risk assessment of new product, which is physical product, and they want to see how it will withstand the hardware attacks. So we had like they requested three scenarios, which of first two was conducted by our security practice team, which is their awesome dudes. And the third one was the one that was asked to do by us, because the thing is that most of the companies can provide to some degree some software penetration testing, etc., but not many of those can do the hardware things. And we are R&D in such a unique place that we have people that can manipulate the hardware to some degree and do some very cool stuff with it. Can you go to next slide?
Yep.
So basically, what they wanted us to do in terms of hardware, also to check the PCB design, because they were afraid that subcontractor who did the PCBs didn't do the good job of preventing the hardware attacks. So we focused our expertise on the port interface analysis, which was actually to check for debugging ports that inevitably will be left on the end user PCB. But the thing is that you can do some tricks to make still product debuggable and release it into the world. Also, they requested the low-level chip attacks, so something like voltage injection and trying to skip secure boot, etc. So this thing is also can be done by us. We have like quite a amount of equipment that can do something like that, and expertise. Firmware dumping, which was also a very big deal, because on the beginning they were using quite a simple flash storage for the firmware, which is not good, and they wanted to make it more secure. And some thing with tampering, they had the tampering sensors, but they're quite easy to evade. So bootloader and secure boot robustness. This is also done with help of our guys from secure practices. So this is kind of I would say cooperation, because from our side we can do some hardware stuff, and they are making sure that bootloader and boot process is robust. And of course, PCB and component review. So we did actually we did a report for them to like make the PCB actually more secure. Of course, it comes with some traits in terms of repairability, but you can make the at least everything is hackable. Yeah, you cannot protect from your hardware from everyone, but at least you can protect it from the people with low engineering skills and low engineering equipment. So the costlier is to hack some product, the less chance that it will be hacked very easily and very fast. Yeah, yeah, and yeah, that's very interesting case, because as I said, we are in the position that can actually facilitate those kind of hardware security tests. Yeah, that's it.
Yep, great. Yep. The last offer is faster hardware launch. Building new hardware usually takes a lot of time and effort. And delays mean higher risk and lost revenue. This approach helps teams to go from idea to working prototype much faster by combining architecture, design, embedded software, and validation in one process. We've seen this bring value across different industries, from smart controllers in cars and connected biosensors in healthcare to edge gateways in factories and fast prototyping of wearable devices. It's a strong fit for product teams, innovation labs, and R&D groups looking to move fast and minimize rework. The benefits are clear: shorter time to market, lower development costs, and stronger position against competitors. And now, Andrii and Yuri will share real case examples. Yuri, please.
Thank you. So for this client, we had quite challenge because we provide some really sophisticated algorithm for the sophisticated device, and the problem actually was for the first that the device was at this point under the development, at least. So it was not yet accepted as a final one. However, we should, using this like preliminary device, provide ready-to-use solution, or at least working solution that were easily adapted to the new hardware, or if this changed. And and also follow a lot of constraints such as real-time power consumption, optimization, because it actually was edge device. And the key point here was to provide some kind of synergy between R&D team, develop the algorithms for computer vision, spatial audio, tracking, like hand tracking, eye tracking, and developer team or engineer who actually implement it on the devices. And following this like methodology, we aimed to quite easily and quickly provide a robust solution and be ready for a future hardware change and or update. And like for particularly this one, as I said, the product was the hardware was quite in dynamic development, but we provided very good solution for spatial audio, for computer vision using a classic and modern approach like ML, embedded optimization for custom DSP and streaming implementation, different protocols. Actually, that's it.
Yeah, thanks a lot. And this case about 3D scanning.
Yeah, that's mine.
Yep.
That's actually our mine and Yuri's because we started this case. It has quite different history than the other ones because this one not from the beginning the client request. So we started this in R&D as the research program. It was driven basically by our curiosity, and after that we actually acquire some clients and get people interested in it. So our curiosity drives us to build actually hardware. So this picture that you see now, the scanner, it's actually a physical thing that is built in here in the SoftServe. Was of course in collaboration with our wonderful robotics teams. They are all pros. So we had built some few solutions already based on our 3D scanner technology. One of those was the gap and flash inspection rig. So what we did in our warehouse, we built a rig that would scan the gaps between the door panels and all the panels on the car. And we actually performed live demo where we like winched the car, and our rig was on the robotics platform that move along the car and measure all the points and presented them to the client. So this it was very interesting project and very cool. The other one was the packaging quality. So this is like previous, and this one, those were already requested by clients. Like we based it on our 3D scanning technology that we did in the software. But the packaging quality assurance was also a very cool project that where they wanted to 3D scan the package, measure its physical parameters, and also do some quality assurance like colors, some tears, and maybe some physical damage, etc. So very basic stuff, and they wanted to store those 3D scans for future use and seamless experience. So no additional manipulation when the scan, just put in place, like click the play button and receive the notification that everything is already done. So that's also a very cool project that we did. And we have actually built several of those 3D scanners with different enclosures. One of them like more suited to the manufacturing, industrial manufacturing, and also one that like for retail, more I would say beautiful. Also, like as a result of the 3D scanning project, we have also 3D scanning SDK that can be used not only with our hardware. By the way, hardware was done also by us, and on the enclosure and PCBs we did ourselves. Yeah, and Yeah, the result of our work, we can also have a 3D scanning SDK that can be used not only with our hardware, but integrated with third-party hardware to do some very interesting stuff with the 3D scans and 3D scanning results. Yeah, I can talk about it forever. So if you are interested, just hit me up.
Yeah, thanks a lot. So now let's shift focus and talk about the trends that shape our hardware R&D today. AI adaptation is growing fast, and it's not longer limited to data centers or cloud models. It's now running on phones, cameras, cars, and edge devices. Every day, more people use AI, and that means more hardware is needed to make it run. This growth brings three critical pressures. First one, efficiency. Every AI request consumes power, and with usage exploding, energy demand both in cloud and on devices is rising rapidly. That's why efficiency is not longer optional. Second, adaptability. As AI moves to the edge, there is growing demand for fast response and autonomy. Devices can't just follow fixed rules. They need to process information and act in context instantly. Third, speed of evolution. As system scales, we still depend heavily on expert engineers to build, tune, and manage them. This creates a bottleneck and highlight the need to automate more of the design and decision-making process. These challenges lead to a new set of expectations for hardware. It needs to be more efficient, adaptive, and faster to evolve. Zooming out the global picture, we see some clear signals. At the global level, energy demand is rising fast. According to the International Energy Agency, data center consumption could double by 2030, and most of that comes from AI workload. That means power efficiency isn't just a device concern anymore. It's a system-wide priority. At the same time, we're hitting a wall with latency. Cloud-based inference is just too slow for real-time use cases like robotics, vehicles, or audio-visual processing at edge. We need AI that can run locally with our device. There is also growing autonomy gap. Most devices still use fixed logic. They don't adapt or improve unless developer updates them manually. As system grows in scale and complexity, we need them to be more dynamic. And finally, there is a bottleneck in engineering. Hardware development is still slow and expert-driven. PCB design alone can take several weeks, and teams are struggling to keep up with pace of product cycle. These four trends, energy pressure, latency limits, autonomy challenges, and slow design workflows, highlight why we need new approaches in hardware. In lab, we translate these challenges into clear design goals: reduce power, run AI locally, build adaptive systems, and automate more of engineering works. So how do we respond to these trends in practice? We focus our R&D on four directions that directly address the challenges we just discussed. First, Edge AI. We build prototype webcam that runs TinyML model locally. It's improved video framing, cleans up audio noises, and does it all without sending data to the cloud. This means lower latency, better privacy, and less energy use. Second, neuromorphic computing. We tested event-based sensors that work more like brain, reacting only when something changed. In early trials, they showed 99% accuracy in detecting subtle physical signals while using far less power than traditional vision systems. Third, agentic runtime. We are building systems that adapt in real time, like HVAC or lighting, using multiple inputs such as occupancy, weather, or time of day. These systems self-adjust, reducing manual configuration and energy waste. And fourth, agentic engineering. We built an AI assistant that speeds up PCB layout by analyzing netlist and suggesting optimal components placement, cutting design time by up to 10x. Each of these projects is either a working prototype or validated concept, and all of them help us move toward faster, smarter, and more efficient hardware. To wrap up, the Hardware Lab was built to help you move faster, reduce risk, and turn ideas into real scalable solutions. We support early-stage validation, prototyping, and discovery. And we are here not just as engineers, but as your technical partners. If you are exploring a new idea, need help shaping a solution, or just want second opinion on feasibility, reach to us early. You can write to R&D community via email. And remember, the sooner we are involved, the more value we can bring. Thanks for being with us, and we're happy to continue the conversation. So we received some questions.
Thank you, colleagues. Before we wrap up, are there any questions? Feel free to write them in the chat or unmute yourself.
May I, since Andrii already asked why I'm here. At first, thank you guys for the amazing presentation. And yeah, actually have two questions. The first one about the actual certification processes, especially regarding the those battery EV technologies, BMSs or stuff like that, and healthcare devices.
We work with compliance in our company, so yeah.
Yeah, so I mean, you will be generating the report that something is compliant with something. Yeah, is it correct?
Yes.
Is the report that you will generate compliant with the requirements from a certification organization, so they can read it and approve further and give the certification to the actual product?
We align all reports and all all processes with current standards in industries. They're different. If we talk about medical devices, it's ISO standards, medical standards, and so on. If we talk about some electronic devices, it's also standards in this industry. So we just help consulting with our compliance team and improve everything and adapt results to these standards.
Yeah, but this is very tricky. The medical field is very tricky. I know that you know that. That's why you're asking this.
Yes. We cannot do it by ourselves. We can only provide technology and, for example, offload the certification to some third-party vendor who actually does the expertise and all necessary, would say, methodology. Yes, because what we're talking about is mostly about policies, not about technologies.
Yeah, and even in case of 3D scanner, as you know, maybe you remember, maybe or not, all the certification stuff was done by third-party SI.
Yeah, and just to follow up about the actual credibility of this report, I mean, how valuable is this report for the certification bodies? Because, I mean, it's a new service and we are new to this field of like generating the reports about something, especially in hardware field. And our reports will be credible when some kind of, I don't know, medical healthcare certification organization will receive them, for example, from our client.
Not medical. Most probably we will not take the medical projects because it's very tricky. But we are not certification organization, you know that. And also, most probably our report is very needed for those kind of clients, because as you know, all the equipments are certified at the end of the development. Yeah, so you cannot take some POC stuff and send to certification. Well, you can, but you most probably fail. So the lower the probability of failure certification will actually lower the cost of the certification, because as you know, if you fail in something, you need to build a new product with all the stuff fixed and sent to the certification center again and again and again. So the less iteration you have, the better it will be for the product. And cheaper it will be actually, because each certification in this kind of lab, it will cost some like big money. As far as we know.
So this report is mostly like roadmap, what should be done afterwards, yes, but it's well-organized report.
Yeah, because we are not the certification body. We cannot say that this product will be is certified something, because it is done mostly by the laboratories that are highly specified in this direction. For example, we would not do something like radio frequency certification or something like that, because we cannot do this, and like our opinion most probably would be valuable for the client, but yeah, without some proper equipment and some very specific stuff, which is very expensive, it's not possible to do. But the kind of stuff that we can provide to customer in terms of overall security of the boards and CPUs and choice of the components, it can be invaluable. And also at this stage, when we are proposing, for example, for the customer, don't use the eMMC storage, yeah, because it's very easy to hack and it can be like dumped and read by any user with the programmer that costs like $2. And use something like UFS or something like that.
Okay, understood. And just one more, if I may, about the automation of board design using AI. How is that compliant with the current standards? Are they changing towards it or not? And how it will work in your opinion?
This is the more generative approach. For example, when you are trying to do some kind of device which customer will interact with, so to take into consideration what device will do to make the UX better. So place the component in the way that will be most pleasant to the user, and of course taking into account all the design rules. It's very tedious task, you know. When you are trying to, you already have the schematics, but place everywhere like components that it would be good for the user experience and according to design rules. So we try to do something like this now. Yeah, we can talk more about it like later if you are interested.
Okay, sure. No more questions from my side. Thank you.
Okay.
Hi, Scott. Do you have any questions?
Yeah, hi. I had a question. Good to see you again, Dmytro and Andy. Andrii, you mentioned there on the last slide about the neuromorphic cameras. I find them quite interesting. You obviously showed me before some of the stuff you were doing with the sugar granulation detection and the impressive result that you had there. Could you expand on that? And could you also expand on the other applications of these that you're looking into for that type of technology?
Yeah. So what you know about the sugar? So we are trying to assess velocity and size of the sugar crystals using neuromorphic camera. Also, we explored things like frequency and amplitude measurement, because we have a small demo that can like measure frequency anywhere in the field of view of the camera, and we can also measure amplitude. So those cases that we already checked and to some degree verified. also we wanted to tackle the blurring stuff and see how it will work. So combination of normal camera and neuromorphic will be used to do the blurring on the normal image. So we are working in few directions which are quite interesting and quite innovative, because as you said, the neuromorphic camera is quite cool.
Thank you very much. I'd be open to brainstorming with you guys about the other applications and how we can kind of tell a story, because I think it is quite a useful application, especially in we talk about process manufacturing and raw material analysis. So it could be, for example, paper, or it could be pharma, or it could be metals and mining, for example. There's quite a lot of applications which are similar to the sugar manufacturing. So I'd love to talk more about that technology and other applications across robotics, et cetera, et cetera. But
yeah, that would be great.
please share as much as you can, because I'm interested to learn more about it. So if you have any documentation, please share to me, and I'll also start to think myself.
Another application very popular nowadays is automotive, using it some kind of lidar or field of depth. Yes, for this kind of cameras.
Yeah, we had ideas around introducing neuromorphic camera to our 3D scanning, but it's more the research than the actual request. So those kind of the vibration and the crystals, it is already on track, ongoing. So we build test setup, rectification column inside our lab to do the crystal stuff. And vibration, it's quite easy to do in our lab also, but everything else we would need to brainstorm and discuss it. Yeah, Scott, thank you.
Yep, I see that's all.
I think we can wrap up. Thank you all for joining today's session. A big thank you to our speakers for the valuable insights shared. If you have any questions, so feel free to reach out us. Stay tuned. Looking forward to seeing you at our next sessions. See you soon.